Okay, so here I want to still discussing on the example 5.17, but then I want to just go through on the question A, where you have to use the direct technique, which just use the surface integral without using the Gauss theorem. So since we have 5 surfaces from the solid that we have, so you have to obtain 5 surface integral. Okay, so now I want to show you how can we obtain the surface integral for one of the surface that we have here. So let's say here I'm choosing the surface 1, which is this one, where this is the wall where y is equal to 0. Okay, so so now because of we want to solve this, so you have to the question here is how can we obtain this one. As I mentioned before, instead of we use normal and unit normal vector, but then we only obtain the normal vector. Okay, so now for the obtain the surface integral for the sigma 1, so we need the we need the equation of the surface. So as we know that that surface of sigma 1 is given by y equal to 0. Okay, so then if y equal to, meaning that in general our function is in this form, y is a function of xz, where we know that our region should be lying on xz plane, right? Okay, now about the component that we that's okay. So now we in order to get the n normal vector here, you have to have the gradient phi, but then we have to find the phi first, the equation, the new form of the equation from sigma 1 here. So you have to make sure that the phi is always equal to 0, meaning that from the y is a function of xz, this one is in general, what we can do is we should make it equal to 0, so y minus f is the function of xz equal to 0. But since this case our f here is 0, so you got y equal to 0, and that will become this one will become your y is your only y is becomes your phi. Okay, so then we can obtain the grade phi. Then we differentiate y with respect to x, we got 0. Respect to y, we got 1. With respect to z, we got 0. Okay, but then in order to determine the n, you cannot directly say that the grade phi is the n. You have to check first whether the correct n is negative grade phi or positive grade phi. How can you determine that? So you have to look at back your sketching here, which is as we know that it is a solid, so part of the solid we have sigma 1. So now what is the direction of n, so that it is what is the n to be positive? Okay, so it should be pointing outward to the surface. This one is a solid, so easy for you to determine the direction of n, where it is always pointing outside to the surface, which is outside to the solid. But let's say you have an open surface. What is open surface? So I give an example here. So let's say your surface is a plane. So a plane, so this is open surface. So this is your surface, let's say given by, so this is your sigma, where the equation of this z is equal to 1, for example. So this is at 1. Okay, so this is open surface. So this is open surface. So since it is open surface, so it is quite hard for us to determine when you say that n always point outward to the surface. Why? Because of it is open. So look at here. So let's say I draw this arrow and this one and normal to the, as we know that normal is always perpendicular to the surface. So since we have a a flat plane, so we can determine directly our n should be that way, or you can have this way. So now how can you determine the correct n, where n is always pointing outward to the surface? It can be both, right? This one, which is z, the component k positive, or you can also determine k negative. But in this case, you cannot choose both of them. You have to just choose one of them. But then how can you determine that? So in this case, the question need an extra information. So normally we take note on this. So in the instruction, they will give you an extra information to help you to determine the correct n. What is the kind of extra information that we can give you? So it is the direction along the closed curve. Why I'm saying closed curve? We know that when you have a surface, the surface should has a boundary. So that boundary, this boundary, is called closed curve. Okay, so in the information, they will provide you the direction of the closed curve, whether the direction is anti-clockwise direction, which is this one. How can we know this is anti-clockwise? When you are standing over here and you're looking down, and you can see it is counterclockwise or anti-clockwise, or it can be clockwise, or it can be clockwise like this. So it depends on the information provided to you. And then how can we make use the information here? So for this, I will explain in detail for when we get to the example like this, after we complete this example. Okay, so now this is, we just leave this for a while. Okay, so now we go back to our discussion on the sigma 1 here. So we want to j to be negative. Okay, so now you have to check your calculation on your grade phi. So is the j component negative? No. Then you have to multiply the gradient phi by -1. So you got 0 minus 1, 0. So remember, when you say that you want to make it negative, it should be overall, all of the grade phi, not only that particular component. Okay, so this is your n now, 0 minus 1, 0. So now we can obtain the f dot n dA. So now we want to get the f dot n. So by using the f given in the instruction here, so we apply the dot product between f and the normal vector that we obtain. So 0 multiplied by x, you got 0, negative 1, 2, you got -2, 0, z squared, you got 0, and we got -2. So then we can substitute our f dot n, you got -2 here. And then now you need to check your region on the exact plane. Okay, so as I mentioned before, this one is very important for you to write it down, because it will guide you to determine which region that you have to focus on. Okay, so now you can see that your region is on exact plane. Then from your sketching here, where is the z plane? So the z plane is this one. It looks like we have a rectangular region. So then you have to take out that region. As I mentioned before, the sketching of the region is compulsory. Okay, so from the sketching, when we got this rectangle, meaning that the limit of z and x, they are constant. So x is 0, 2, z is 0, 4. Then it is up to you which order that you want to use. So here I'm using dx dz, and I plug in the limits, and then finally I just compute. This is not so complicated, and I got -16. So this is the result of one of the surface, but then you have to provide another 4. Okay, so now how you can imagine how complex they are. I mean, this is not complicated, but it is tedious. Okay, so I just leave this for you as an exercise. Okay, just you have to take note, you have 5, so one of them we already obtained, which is y equal to 0, so this is done. You got minus 16 here. Okay, so then you have to provide the floor, and then z equal to 4. Okay, and then you have to obtain the front wall, and also the surface part of the cylinder. Okay, so I just leave this for you to do as an exercise, and at the end of the solution you have to total them up, and finally you will get the same answer. You got 20 pi, where we already obtained from the previous video that using the Gauss theorem you also get the similar answer. Okay, so please, I'm begging you to try this yourself, because all the answers are given. Now your task is to prove that. Okay, if you got problem, you cannot get the answer, then please let me know. Okay, and maybe this one you got stuck in order for you to integrate, but it is good for you to explore how can you integrate this with respect to x and so on. Okay,